Yama, and welcome to the Young Space Explorers Careers webinar. I'm Heather Catchpole, Head of Content at Careers with STEM, your go-to hub for careers that combine foundational skills in science, technology, engineering, and maths with your interests. At Careers with STEM, we want you to discover the careers of the future, and we're super excited to be bringing you some info on space careers today and the opportunity to chat with some amazing panelists. We have someone who's been to the International Space Station. We have an expert on Mars rovers. We have someone from the Australian Space Agency, and also the opportunity to chat with an incredible tech entrepreneur who is all about the future of learning and the future of space as well. Before we kick off, I would like to acknowledge the traditional owners of the land where I'm coming from, the Melakirti people in Lutruwita, and pay my respects to the elders past, present, and emerging. There are, of course, tens of thousands of years of astronomical storytelling and know-how held by Aboriginal peoples, and that allow them to better understand the sky, space and lands that we're coming from, and really worth looking up where you're coming from today and finding out what some of those traditional stories are and what that kind of deep tens of thousands of years of knowledge can tell you about your space. We're all about space careers today, and we aim to be as interactive as possible. So we will have some questions for you coming up via the AHA slides. So look out for that code that comes up on your screen. We'll also have the opportunity to ask questions via the Q&A function, which you will find at the bottom of the screen today. So get your questions ready, and I'll give you a heads up for when those times are coming in as well. So space careers, why are we talking about space careers and what even are space careers anyway? Well, you might be surprised to find out just how diverse careers in space can be, and also how much opportunity there can be in space. The Australian Space Agency is aiming to get another 20,000 jobs in space for you by 2030. So there's a lot of opportunity. There's also an estimated 1.2 million jobs, which we need to create in technology as well. So a lot of these careers in space are technical, but a lot of them are careers which can involve working in law, in communications, and creativity as well. Working in space could include careers such as space specialist lawyers, cybersecurity specialists, fabricators, electrician, game developers, machinists, robotic technicians, flight surgeons, astronauts, astrophysicists, software engineers, and so much more. So there's also many pathways to get to these space careers. So if you feel like a bachelor is not for you, you don't have to study science. You might study computer science. You might take a VET pathway. There's a lot of postgraduate research areas you can do, but you can also get into graduate programs, and there's a lot of companies that are out there really looking to employ people and really looking for different ways to get you in there and to help you get into that space career. In this webinar, we're going to review some of those employers at the Australian Space Forum, which happened, the Young Space Explorers Forum, which happened last week. So we're going to take a quick look at that, and then we're going to jump into our panel and find out a little bit more about that. So we'll just cue that quick video from the event last week and then jump into our panel.
Cassie from Careers with STEM. We're all about exciting students about science, technology, engineering, and maths. Today, we're down here at the Young Explorers Space event, looking into all the awesome career opportunities for students in Australia's booming space sector. Today, we'll be chatting to industry experts from places like Lockheed Martin, the Australian Space Agency, the Defence Workforce, and so much more. Let's get going.
I'm the Chief Engineer for Lockheed Martin for Australia in our space division for satellite communications. In Australia right now there's a growing recognition of how important space is to our life on Earth, and a recognition by the government about how important the space industry is, and the number of companies that are starting in Australia that are in the space industry is really, really exciting. Australia is really coming to the party now. We're involved in the Artemis mission to the moon and lots of other great international projects as well as our own in Australia.
Industries like space, they're really important for people like me to be in so that we can, influence people to be more sustainable, be more transparent with their sustainability practices. And I would really love to learn how to use space technology for conservation purposes.
So if you choose to study STEM subjects, for sure you're going to learn science and technology and engineering and maths. You're also going to learn teamwork, understanding that these projects, they're quite complex and a lot of skills have to come together. So teaming, communications, you're going to learn that in spades. We need people skills. We need thinking skills. We need problem-solving skills. We need communication skills. We need skills in ethics, legal skills. There are so many areas that the space sector is going to need future people just like you. Australia and the space sector needs skills in every way that you can imagine.
How cool's today been? We've seen rovers, we've seen rockets, space shoots, and heard about some seriously cool jobs. And the best bit, by 2030, the Australian space industry is expected to hire over 20,000 employees, which means there's some seriously cool jobs going. For more study and pathway inspiration, head to careerswithstem.com.
All right, we're going to queue up our first question for you students first up. So if we bring up the QR code on the screen and you can go to that and answer these questions live. I really loved, meanwhile, while we're bringing that up, what Kira Crystal said about working in conservation. If you can work in space, there's some amazing technology. Everything that you do towards a space career has some kind of benefit here on Earth. I think, finding koalas after bushfires using drone technology and satellites. I also really loved what Russell Boyce from the Australian Space Agency said about the kind of skills that you need in space. They're not just technical skills. We also need teamwork, problem solving, creativity and communications as well. So we'll just kind of bring up the first question for you about space careers. The question is, the Australian Space Agency is working to triple the size of our space sector and create how many local jobs by 2030? You have 15 seconds to answer this question, and let's see who can answer the fastest. Keep an eye out also for the Q&A. We're going to bring up our first guest soon, and I am going to kick off that. Find out first how many of you got to that answer. How many jobs are they looking to create by 2030? The answer, of course, is 20,000 jobs, and you're all getting there. So thanks for listening. Love it. So let's introduce our first guest without further ado. Adrian Brown is the Deputy Program Scientist of the Mars 2020 mission and a planetary science researcher at the NASA headquarters in Washington. And he's coming there from there today, and we're super grateful for that. After receiving his electrical engineering degree, Adrian served with the Royal Australian Navy as a weapons engineer and fire control officer. He's also a qualified single-engine pilot and has flown aircraft over the 3.5 billion-year-old rocks of the Pilbara region, which is an awesome Mars analogy, actually, that area. And he's done that to simulate the action of a drone on Mars, which is pretty cool, in much the same way that Mars helicopter Ingenuity will do on Mars itself. Adrian is a certified Java programmer and has worked as a software engineer for a variety of commercial projects. Welcome, Adrian.
Thanks very much. And yeah, it's great to be here. Thanks, Heather.
Fantastic. So, we always get pretty excited to talk to someone who's worked with NASA. Can you tell us a little bit about what the project is that you're doing with NASA now?
Right. So I'm actually a deputy program scientist on the Mars 2020 mission. So I'm a scientist now, but I work on trying to work out the best places to take samples from the rocks that we're at the moment, because the mission is the first leg of our Mars sample return journey. which will eventually see some of the samples that we pick up from Mars return to Earth. And so that's very exciting.
That's pretty amazing, the idea that we can actually get rocks from another planet. And of course, I guess sometimes people think that meteorites might come from Mars and come here, but to actually get a chunk of Mars and hold it in your hands, that'd be pretty amazing. You worked in Australia as a kind of, I guess, some people talk about Australia as a Mars analog because it's got some pretty cool old rocks here. Why is Australia a great place to study if you want to learn about Mars?
Right. So Australia has so much cool stuff happening. It's really the oldest evidence of life that happened on Australian soil or is still preserved in Australian rocks. So we have the oldest rocks, and we have these things called stromatolites, which are like microbial mats of which have been locked into rocks. They look a little bit like cabbage layers. And so we're on the lookout on Mars to look for those type of what we call biosignatures or signs of life that have been preserved in Martian rocks as well. So if I look at these old rocks and stromatolites on Australian soil and on the beaches, and especially at Shark Bay, for example, in Western Australia, there's fantastic a colony of stromatolites there. So Australia is just packed with things that we're looking for on Mars, and that we're very excited about finding on with Jezero Crater where we landed.
Fantastic. And we went from sort of looking for like Martians with bug eyes to looking for Martians with tiny cellular features and really hidden in the rocks. And I think that's really cool that we know more about what to look for and can really use geology and technology and different ways to look for those kind of signs on life, which is really exciting. Your personal background, you have skills in technology as well as engineering. What skills would you say that students should aim for if they want to work in space technology?
Well, I think STEM just sums it up. Science, technology, engineering, or math. Basically, that was where my career started in engineering and then moved over to be more science oriented. But I mean, you always benefit from a broad background. Engineering provides a broad background gives you management type of skills as well. So and they're things that you look to use throughout your life. When tricky problems come your way, you start to think about ways of thinking about things as an engineer. And so having a different wide experience as well enables you to look at problems from different angles and also not get worried by problems and see things. Problems that just are interesting to when you look at them from the right angle, and rather than a challenge, it should be viewed as something like an exciting type of opportunity rather. So with broad experience, I think you get more of an idea of how useful problems can be.
Yeah, I love that. It's about breaking down those problems into smaller chunks. So the idea that the kind of engineering and maybe computational thinking approach you can take to problems can get you a Mars rover all the way. And I think you had a slide to show about just the kind of challenges involved in getting something to land safely on Mars and do some science, and some of the examples of the rocks that we've been seeing up there as well. So yeah, I'd love you to show that. And while you do, if those listening can pop their questions into the Q&A for Adrian. If you have a question you've ever wanted to know about what it takes to get to Mars, to get a Mars rover going, pop your questions in the Q&A now. And Adrian, can you tell us a little bit about what we're seeing here?
Yeah, so this is the Mars sample return arc, if you will. So this has just recently been updated. So this is up to date as of today. So essentially you can see our rover up here in the top left-hand corner. And then over here we have the Mars launch system, which has to get off the surface. And then we actually go back to Earth with this satellite back here, and then back into the Earth entry system as well. So we have to make sure that we break the chain here to try and make sure that we don't get any Martian. Basically, we don't want to fool ourselves by putting terrestrial microbes and getting confused about the terrestrial microbes that we bring with us. So we have to be very careful about
Mars,
that.
you know, oh wait, we didn't.
Yeah, precisely. So yeah, we're up to this stage now. We're actually in the next couple of weeks, we've just finished taking our what we call our regolith sample, which is a sample of a dune. We took 2 samples of the dune, and we've got up to sample number 17. I'll show you those in a second, but essentially we're going to drop those off in the coming 2 weeks in December into a what we call an initial cache, which is basically a backup if the rover was to stop working for some reason in the coming decade, and we weren't able to use the rover to hand over to the sample return rover, sample return lander. Then we'll have a backup plan of sending helicopters, essentially helicopters that will pick up the samples that we're going to be laying out in the next 2 weeks. And so we'll always have that initial cache there, just in case something goes wrong with the rover.
Fantastic.
I'll just show you that.
Yeah, if you flick to that next slide of the samples, that'd be fantastic. And in the meantime, we've got a question come through from Coffs Harbour Public School. How long did it take to complete the Mars rover? Right.
So the rover was actually built, or was first kicked off in 2011, and then they had a lot of planning and phase A stuff, as NASA calls it, happened in 2013. I joined 3 years later in 2016, and then we had the landing site selection happening from 2016 to 2020, and then we launched on. It took us 7 months to get there to Mars, and now we've been on the surface 640 Martian sols now as of today. And this slide just shows you where we landed and where we've been going. This white line shows you where the rover has been going, and all of the samples up to number 12. There's actually 5 more samples, including the regolith sample that I mentioned. But these are the first 12 samples that we took, and you know, they look a little bit like the rocks that you might see on the surface of your in your backyard or something like that if you cut them up and put a bit of water on them. So they're they're very exciting. I'll just note that our first attempt at sampling, we actually failed to get the rock back into the rover, and that's why it has this what we call the atmosphere sample now,
right,
to cover up our mistakes there.
Fantastic. That's so great to see. And yeah, great to see those questions popping in for Adrian. Adrian, if you're happy to stick around, would love to get you to answer some more of those questions later on. And thanks for showing that and bringing that awesome picture. I just love to see that of the, you know, rocks from another planet close up. That's just incredible, the science and the engineering that it's taken to get there. We're going to pop up another question from the AHA slides for the students out there. So if we can grab that next question and get your phones ready to answer that as well before we pop onto our next guest. Our next question, I think if we just got that coming up on the screen there, we're going to talk a little bit more about the kind of careers that you might go into. What type of tech pro maintains complex operating systems used by both astronauts and space flight controllers?
Am I allowed to answer?
I don't think so.
Okay.
So you've got about 10 or 15 seconds to answer that now. And just see if the answers are coming in. Your options are user interface designer, software developer, penetration tester, that's a cybersecurity specialist career, and network engineer. And we'll just see the answer coming up on the screen. We have quite a few for network engineer, quite a few for software developer, which is the correct answer. Well done to all of you out there listening. And we will jump into our next guest now, who is Alice Fairey, Senior Programs and Operations Officer at the Australian Space Agency, who fully looks like she is coming to us they're coming to us to the moon there. Alice completed a Bachelor of Science in Physics and Chemistry at Sydney University, and then joined the Questacon Science Circus, where they got a Master of Science Communication. Since then, Alice has combined their lab and communication skills to work as a science presenter, a fairy for a children's entertainment company, a biomedical field technician and engineer, and a lab manager at a high school, before finally joining the Australian Space Agency in 2021 as a space communicator and then a Senior Programs and Operations Officer. Alice, it sounds like, thanks for joining us, and you've had an amazing career background and really amazing career now. But your background, I guess, was in science. Do students need to study science to work in space careers in Australia?
Not at all. Science, tech, engineering and maths study obviously is useful and gives you a great foundation for a lot of different things that you could go on to do. But by no means are necessarily even most potential space careers based in science and engineering. Things like space law, for example, is a long-established field. We need philosophy and ethics as we increase our space use. So I work at the Australian Space Discovery Centre, which is part of the Australian Space Agency HQ. We're on a precinct called Lot 14, where we share the area with a lot of different space companies. So in preparation for our panel today, this week I've been asking around a lot of people on the lot and from the agency what their background actually was. And I've found people who've studied media and communications, journalism, law, of course, a number of engineers, often working in fields that aren't obviously engineering, like in space regulation. I've found an architect who is researching ways to make safe and comfortable habitats for people to live on the moon.
Wow.
I've found people who haven't done any uni study at all, people who've come through TAFE, people who've come through the Defence Forces, and even a few people straight from high school into space industry jobs. So yeah, it's a very, very broad and diverse field. One of the things that we often say when we're talking about careers at the Discovery Centre is basically anything that humans do and need, we do and need working in and with space.
Yeah, fantastic. And I love that, we're going to need a lot of trades out there. We're going to need, a lot of people thinking about designing and how we approach, even being out in space is such a huge challenge. Can you tell me a little bit more about the Space Agency and about your job as Senior Programs and Operations Officer? What does that involve, and what are the sort of focus of the Australian Space Agency? Why do we need a space agency?
Yeah, so the Australian Space Agency is fairly young, and we've grown up as a way to support the Australian space industry that has been growing over the last decade at an incredible rate. We're focused a lot on making sure that everyone's able to use space fairly, safely, and that we get opportunities to work with international partners, because it is inherently a very international industry as well. My job at the Space Agency, first as a space communicator, is to get to basically chat about space with people. So what I love getting to do is, help people find out things that they didn't already know about how we're using space and space opportunities for Australians, and find out how that aligns with their interests and passions, and shows pathways, shows opportunities, and just shows interesting stuff for our daily lives, our existing interests aligned with space. For people like our audience, it's also illuminating the potential career pathways and study pathways. If you're keen on space, but also keen on filmmaking, or game design, or of course, science, engineering, trades, I get to, chat and illuminate potential pathways that you can get your passions for space and whatever else to mesh up. In the Senior Programs and Operations Officer role, that means I actually get to design our educational programs as well, and our school experiences, so our shows and talks, and oversee that and make sure that, we're doing the best we can, and making sure that we're bringing things that you're interested in to you.
Fantastic. I love that. And that's so jealous of what we're about at Careers with STEM, finding what you're interested in and then seeing how you can combine that with STEM to, be more likely to get into these exciting jobs of the future. And I'm sure you can find a lot more of those jobs out there, and a lot more about the Australian Space Agency. Quick question for you from Lake Macquarie High School. What does the future of the Australian Space Agency look like? For example, what are the kind of projects that you might be working on next? What's the next 5 years look like for the ASA?
So, as I said, the agency is very much focused on supporting other Australians working in and around space, and creating these international partnership opportunities, and assisting people to get their ideas out there, make them real, actually get, I'm trying to avoid the pun of get your startups and your ideas off the ground, because
But we want more businesses, right? We want more, more ideas, more architects making hubs to live in space, more, people thinking about what they can bring to the table, and kind of boosting that and boosting our capacity.
Which one of the big opportunities that are coming up in that the agency is working with and supporting is the Moon to Mars initiative, where we're joining in on the massive international team up with NASA to get a human presence back on the moon, and with the plans to then use that to head on to Mars. So all of the support and technologies around that, around getting people safely up to a moon base, and all the research that needs to happen first, and planning, that is one of the massive, already in progress and increasing and upcoming things to look out for over the next 5 to 10 years.
Fantastic. Thank you, Alison. We have one of those people who have actually gone to space and has had that experience coming up next. But first, another question for you. If you bring up the slides again, talking about different careers in space, tech professionals are also needed in the space industry. We've heard about what a huge job it is and how we need to kind of break down those sort of programs. But what kind of tech professionals would we need to keep data transmissions safe, would you say? What role would be ideal for this? And again, 15 seconds to answer this question. Would we want an AI researcher, a product manager, a cybersecurity expert, or a machine learning engineer? And have you ever heard of any of those jobs? If you had, it's well worth looking those up as well. But it looks like we have some super knowledgeable students here all going for cybersecurity expert, which is, of course, what we need here on Earth and in space as well. So awesome space role. Imagine trying to keep data safe in space and what that means. Fantastic. Thanks so much, Alice. And please do stick around for some Q&A coming up. But I'd love to introduce our next guest, who is coming to us again from the East Coast of the US, which we really appreciate going into your evening here. Sandra Magnus is an American engineer and a former NASA astronaut. She returned to Earth with the crew of the STS-119 Discovery in 2009 after having spent 134 days in orbit. She was then assigned to the crew of the STS-135, the final mission of the space shuttle, which must have just been an incredible, history behind that space shuttle. I remember my sister building one when she was little, and just seeing that. It was so huge to be part of that. From 2012 to 2018, Sandra was the executive director of the American Institute for Aeronautics and Astronautics. Welcome, Sandra, and thank you for joining.
Oh, thank you for inviting me.
It's just so exciting and such a privilege to talk to you. And I guess the question that, maybe comes up for most people, and I'm sure you've answered a lot, but, what is it like on the International Space Station?
Oh, it's such a magical place. I had 3 missions up there, even though only on one of them did I live there. And each time I went over the course of my career at NASA, it changed because we spent, a decade or so building it. And so every shuttle mission, it grew bigger and bigger. And it was it was always amazing when we were rendezvousing and docking with the space station. It starts out as this tiny point of light. And as we get closer and closer and closer, it gets bigger and bigger and bigger. And it's like, wow, look at this amazing building. It's this huge building that we've built in space. And to live there was a pleasure and an honor. And a lot of people, when I hear I've lived in space for 4.5 months on the space station, they're like, oh, wasn't it claustrophobic? And the answer is no, because it's so huge. And it was just such a wonderful experience, and to look out and watch the Earth go by anytime when I was working. We have an amazing planet, and to watch the views go by. I could tell when we were over Australia, the light that would reflect from the outback was a little bit more of a reddish color than the light that would reflect when we went over, say, like the Sahara or other areas that were of similar geology. So you really get to know the Earth well when you see it so often. It was a wonderful experience.
Wow, fantastic. And what an incredible achievement that we have, done that, and to see that in person, and to see this kind of collective of humanity. I really love that space careers are super collaborative, and when we talk about going to space and these big kind of aspirations, we need to work together, and the kind of boundaries between countries and institutions and things just disappears, because it's such a kind of human goal to get to space. It's really cool.
Yeah, and if I can insert, I think one of the fun things, besides the flying in space part, which of course is the highlight of what I did at NASA, but the fact that I got to collaborate with people from all over the world, and we all shared this common goal of advancing human spaceflight and advancing technology to achieve human spaceflight, that was really an unexpected pleasure and surprise, because that was never in my mind when I first dreamed of being an astronaut, that I would actually get to work with so many people all over the world. And it was just so much fun.
Yeah, that's really amazing. And I know that we're going to have a bunch of questions coming in for you, but just looking at your own background, you studied physics and electrical engineering. What would you say that students today should study if they want to get into a space career? And obviously, being an astronaut is like way up here. Is it really competitive? Do you have to be the best of the best, or are there, what are the kind of what would you say? How would you kind of approach that if you're like, okay, what should I study? I'm really inspired about this. Where should I go next?
The most important thing that you should study is the things that you're interested in and that you're passionate about. That's really what happened with me. I started in physics because I was really curious about how the world worked. And quite frankly, I didn't even know engineering existed as a field until I got to college. And then I found out about engineering, and then I got really interested in the fact that I can take all this information that I was learning from physics about how the world worked, and I could apply it to build things and to make things. And that's really how I followed my path. But your path should be follow your passion, and understand that when you start, you might not know about things that are going to interest you until you start on your path. Just like I got to college and discovered electrical engineering, and then I got into the working world and discovered material science. And actually I studied that as well in my graduate career. So follow your interests. And then, astronaut, yeah, it's competitive, but what's really interesting for all you students out there is there's going to be so many different ways to fly in space than when I was, the options that I had when I was starting my career, because it's opening up to non-governmental, I was a government employee as an astronaut, and it's opening up to non-governmental jobs. And what you're going to see in the arc of your career in the next 40 or 50 years, I just have no idea. And I will tell you too that when I was a little girl dreaming of being an astronaut, I had no clue if I was going to be able to do it or not, but I knew that I had to try because it was my dream. And really 99.9% of success in life is just determination and effort. So if you have a dream and you've got a passion about something, you owe it to yourself to go for it, regardless of what that topic is, whether it's a STEM topic or, we talked about all the other areas that the space sector needs, all the other fields, and just follow your dream and follow your passion.
Wow, that just feels so real coming from you, who's really made it happen. Going to a question now, because everybody can't get over the idea of being into orbit, and it's just so cool. Question from Punch Bowl Boys High School: how long did it take you to readjust to Earth when you came back from space?
Oh, that's a really good question, because, as a rookie astronaut, especially, my first mission was a short mission, right? I was more worried about adapting to microgravity because, of course, I'd never been there before. And then on shuttle missions, we get to space and it's just like busy, 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 busy. And you don't really have time to get used to it. You just have to start working. But it was fascinating to me, number one, how quickly I adapted to zero gravity. I felt like I'd been there forever. The freedom to move in all directions was just amazing. But then as we were re-entering, even again, first mission, very short, and I started to understand what gravity was. All of a sudden, I was sitting in my seat holding my checklist, and we started to re-enter Earth's gravity well. And I'm like, oh my gosh, I have to use my arm muscles to hold the checklist up. This is so weird. And then there was this force that came out of nowhere that was just pushing me into my seat. And it was very bewildering. It's like, this is gravity. This is horrible. And so when we landed, and even after my long duration mission and then my third mission, I was strong, because if you exercise in space, you can come back strong with no bone or muscle loss. But the fluid in your inner ear that kind of tells your brain what attitude you're at, whether you're, moving your head around, that's all messed up. And so it's really easy not to necessarily be dizzy, but to be very unsteady on your feet and to feel very, very heavy for a little while. So it took, and then, after a few days, you kind of get used to it. And after my long duration mission, it took a little, more like a week or two to get used to it. But you do have to readapt to gravity.
Fantastic. Kind of an extension on this question, one from, I think we've got time for one more, from Wollongong Public School and also from Redfields College, want to know, about the kind of health effects, like do your spines decompress in space, and did you have health issues such as, fainting or other kind of problems that went with returning on that? And I guess, how do you kind of avoid that?
Well, again, while I was in space, I exercised every day, and that keeps the bones and the muscles and everything strong, right? We also tend to shed fluid. So before we return to Earth, we have to drink a lot of water or Gatorade and take some salt tablets and rebuild our fluid loading so that we don't get faint or anything, so our blood pressure can return. Interestingly, without gravity, our spines stretch because there's gravity's not pushing you down so hard like it does. It's really horrible. I'm not kidding. And so my spine stretched probably about, I don't know, maybe 4 centimeters.
Wow.
While I was in space, 3 to 4 centimeters. Of course, the minute we land, gravity just pushes it all back down again. So some people have, lower back pain occasionally as, all that tissue in your spine is getting used to moving around. But generally speaking, while we're on orbit, while I lived on the space station, I had a physical exam every 30 days. They would do a heart test and we would take blood. And so they keep pretty good track of us. And there's not any really long-term health effects that we're finding. NASA continues to do studies on us. I'm a medical guinea pig for the whole rest of my life as we look and see if there's any longitudinal, lifetime issues that have to do with being in space for so long. But so far, so good.
Amazing. And there's another great space career, if you're into health or, sports science and athletes' health and physiology and things like that as well. So many applications there. And thank you so much, Sandra, for joining us. If we have time, do stick around. I think we've got another 5 minutes and we'll definitely get another question to Sandra if we can. But we really appreciate you coming, and just the, inspiration of hearing your stories is really phenomenal. So thanks for joining us.
You're
I'm going to move
welcome.
straight to our last guest, Ted Tagami, who, having built and sold his first .com in the 1990s, has been building internet relationships since 1994, which for anybody who needs to know was literally when the internet was really just first taking off. With leading work at Knight Ridder Digital and global brand experience at the digital agency Millions of Us, Ted brings a unique perspective to modern experiential learning through the implementation of science and engineering based on the next generation science standards. He also serves as the education chair for the User Advisory Committee of the International Space Station US National Lab. And just, such an inspiring kind of career story there that we've got to unpack in the next 4 minutes, Ted. Thank you so much for joining us.
No, thank you, Heather. It's just so amazing to hear from Adrian and Alice and Sandra. They're esteemed and qualified to really speak about space. I went to art school, so my background is definitely orthogonal to any of that. And I'm inspired about human possibilities. And that's pretty much what led us to form Magnitude back in 2013. But literally above our heads, about 400 kilometers above the planet, is the International Space Station. We have a mission on it right now that a number of schools right there in Australia, really schools around the world, are participating in. As we think about like hardware and software, rockets and satellites, there is so much more in space. And as you've heard from our other guests, it really is across disciplines, this kind of transdisciplinary notion about the future. As Dr. Russell Boyce says, space is a domain, right? It's not a study, if you will. It's something that affects us. In low Earth orbit, it's a little different than in the deep space outside of Earth's magnetic field, like on the way to the surface of the moon or on the way to Mars. And we're just now at the very beginning of human discovery and human space flight. There's just, as we heard from astronaut Magnus, there are a lot of problems the human body goes under. I was really curious about living organisms in space. So we've been studying plants for a lot of different reasons. And one is they're a lot smaller than humans and they require a lot less extra stuff to bring along with them. And we were looking at that for a couple different purposes. One is to make life better here on Earth. Without plants, we really wouldn't have humans and mammals and everything else. It's a wonderful relationship we have with the rest of the world.
We'd miss it, right? Like if you're living on a planet and you didn't see plants around you, you'd just be like, okay, that's one of the kind of important things about potentially finding our kind of home in space.
Exactly right. And a big differentiator between, let's say, the moon and this path to go to Mars is Mars and the moon right now are dust and rock. We have living soil here on our planet. It's not just dirt. The mycorrhizal fungi in there and the bacteria is in there. And there's a lot of amazing things that happen down in the rhizosphere there in the root level. It just absolutely fascinates me. And most often the most ignorant guy in the room. I've never minded asking questions. There's a perennial 12-year-old inside this old guy. And when you're around very smart people and you're asking questions and taking notes, you can actually start learning some stuff. Hopefully learning is a lifelong experience for you and not just something you get a certificate that says you've completed something. And so as we've heard from others, follow your passion, follow what you love. And with that, we talk about STEM often, the science, technology, engineering, and maths. As an art guy, I love the A in there, but I like to rearrange the letters. And when we rearrange the letters, we can spell teams, technology, engineering, art, maths, and science. And without coming together as a team, Heather, we couldn't do anything, honestly. So I can bring my creativity, but I can't do anything without the engineers. And I can bring my creativity, but without actually the science domain, I can't actually do the research. And so we're really blessed by having like the Lawrence Berkeley National Lab or the Joint Genome Institute, being able to do things like hard X-ray tomography and single cell transcriptomics. It sound like super big words, and I know a little bit about what that is, but when they're able to break it down for me as a layperson or able to share it with you as students, that's when the wonder begins. At my age, what I've got to learn is to move aside fast enough for all the brilliant minds I've been meeting around the world. And I'm really grateful to be here with you guys all.
Yeah. And I think that's really important because, you know, we need to get the next generation thinking about what they're going to do into space, and the idea of inspiring that and building those kind of projects. I know a lot of the students out there and a lot of the teachers are like, oh yeah, plants in space, great, you know, great project, or designing something that might go into the International Space Station. Check out Magnitude.io, and you can definitely, you know, find a way to, you know, think about how you might actually get a project into the International Space Station. There's some really cool projects out there, and you know, yeah, comments there going, I love the teams over STEAM. We have a question from East Hills Girls Technology High School, which is really fascinating. I'll throw to you, Ted, and I think we'll just have time for one or two questions for our other panelists. Are there ways where arts or law could be used in space?
Just imagine what we do here on Earth as we look at putting settlements on the surface of the moon, or planning for those, or thinking about living on other worlds or in orbit around them. Whatever you see here on Earth will be needed in beyond the planet's surface, probably even more so. But if you look at like the Star Trek future, we're all really going to have to learn to work well together. It's going to be really hard to colonize the galaxy if we're still constantly fighting each other. So let's work on that here at home, and maybe we can extend that beyond to the surface of the moon and to Mars. At least I sure hope so.
Fantastic. Thanks so much, Ted, and thanks for joining us. Quick question for Adrian. What was the most unexpected part of working on the Mars rover? That comes from Crestwood High School.
Yes, from working on the Mars rover, we did learn lots, and for example, as I mentioned before, we've had a lot of problems on the rover. For example, we lost our first sample. And we were very panicky about whether we'd actually be able to ever get another sample or something like that. But it turned out that we'd just been a little bit optimistic with how we were getting the pulling the cores out of the rock, and we haven't had that problem repeat itself. So yeah, we learn more every day about how to operate the rovers on Mars. It's always an exciting time working with the rovers day-to-day basis, and sending up new instructions to them overnight and seeing what comes back.
And I love that you had to push through a fail there. That must have been quite a moment, but you pushed through and got all of those other samples as well. Fantastic. Thank you, Adrian. Quick question for Alice, Absolutely. Super relevant to getting careers. How do I get a job in the Australian Space Agency after I graduate in high school?
That really depends on what you're keen on. So if you're looking at trying to get straight into the space industry out of high school, based on the people that I've been chatting with this week, as I said, just sort of surveying all my friends around in the industry, a lot of the type of normal business roles that you'd get in administrative and operations kind of roles that you might take out of high school in another company, they exist in space companies too, of course. If you're looking at further study, there's so many potential pathways. So if you're thinking trades, there are space industry parks coming up in both New South Wales and South Australia, I'm aware of specifically. If you're looking at engineering, there are so many opportunities. Software development and programming is another one that a lot of space companies are looking for people specifically with those skills at the moment. But really, like Sandra said, look at what your passions are, and you can find a way to make it work with something going on in space. Another great resource is your state's Space Industry Centre. So if you look up New South Wales Space Industry Centre, if we've got any interstate people joining us, again, your state Space Industry Centre, you should be able to find some information about what is going on very specifically in your state at this point in time. And that should point you to some opportunities that you can seize as well.
Brilliant. And there are some amazing growing companies in Australia, particularly in satellites. We're going to finish with one last question for Sandra from John Monash Science School. How is scientific investigation and experimentation different on the International Space Station compared to labs on Earth?
Well, that's an excellent question, and I'll give you one word: microgravity. Remember, I talked about how horrible gravity is. Well, the reason why we have the International Space Station is so we can do experiments and investigations in microgravity, a very tiny amount of gravity. And what happens is, in the absence of gravity, different kinds of physical phenomenon reveal themselves. And that helps us not only advance our knowledge about how we can build and do things on Earth, but also about the technology we need to build to go further. For example, you can go on YouTube and you can look up pictures of astronauts playing with, we love to play with water, for example, and you'll see astronauts little spheres of water floating in front of them. And that's because something called surface tension takes over and drives the behavior of fluids in the absence of gravity. And so by doing all kinds of different experiments on fluids, combustion processes, materials and how materials grow. Again, I'm a guinea pig, so even how the human body operates in space, we're experimenting there. We heard something about plants earlier and how that behavior changes, or how we can understand that. So in the absence of gravity, we can learn so much more about the world around us, which strengthens our ability to design and build things here on Earth, but also to help us understand how to build the technology we need to go to the moon and put people on the moon and eventually go to Mars. So it's really a magnificent laboratory.
I love what you say too about just, increasingly that, what we do for going out to live in space is always relevant to benefits on Earth as well. There's always some kind of spin-off or knowledge that we get about living on our own planet that comes out of this kind of research as well. A follow-up question from Veronique wants to know, do you get claustrophobic on the ISS? You mentioned this before. How big is it? It's quite a big building.
Oh my gosh, it's huge. If you take, first of all, never got claustrophobic because it's huge. So if you go look at a picture of the ISS, and there's the modules, the cylindrical modules that's the main spine, and then there's that big truss that goes across with the solar rays. So that truss is about the length of a football field, right? A football pitch. And the cylinders end to end are also they're just shy of the length of a football pitch. And so there's a huge amount of internal space on the space station. Amazing. And it's just huge. So no, claustrophobia is not a problem. Actually, it's easy to lose things. Just like you lose things in your house, you can lose things.
I bet that would definitely be a problem for me. Going to Ted and thinking again about life on other planets. Tamworth at South Public School would like to know, do you think that there are other life forms like us on other planets?
Oh my gosh, I'm not qualified to answer that question, but I have to suggest yes. It's such a big, super big place. We don't even know the extent of the universe. We have the James Webb Telescope looking deep in the very origins, and just look at life and chemistry and what have you. It's around. You just have to look at it. And Dr. Brown, what he's doing, hopefully he can bring some samples back. Maybe we'll find a little microbe or something that looks like life has been there in the past. We've got other moons just in our own solar system that might harbor life. Maybe life isn't what we expect it to be. We're carbon-based life. I've heard people talk about silicon-based life. Just to me, everything is super fascinating. And I'm looking forward to hearing from you as each of you are growing up and getting into your careers, whatever it may be, thinking about things maybe we haven't thought about yet, or perhaps some new paper or discovery a young scientist or engineer today is discovering you can build on, because they're just now starting to reveal what that might be. We live in very exciting times. The Artemis missions, going back to the moon. I was just a little kid watching them land on the surface of the moon, and you get to be a part of it, and you can bring whatever you like to it, whether it's arts or whether it's the sciences, whether it's law or engineering. Really looking forward to everyone's stories.
Fantastic. And we did hear from Lockheed Martin that Australia is involved in that Artemis mission to the moon, which is really exciting. Challenging problem for teachers and students. How would you discover if there is life on other planets? Like, what kind of experiments might you need to design to listen for or look for signs of life on Earth? There's a lot of interesting physics and electrical engineering in there. I'm just going to run to a couple more final questions. Adrian, John Monash Science School asks, how do you deal with any problems that might happen on Mars? Problem solving from how many kilometers away? Many hundreds of thousands of kilometers away. How do you go about dealing with those kind of problems?
Right, that's a great question, and that's what we do every day, because this is a day-to-day mission. Things happen to the rover that we don't expect, but the best way that we have to troubleshoot our problems is that at the Jet Propulsion Laboratory in Pasadena, they have a duplicate rover called Optimism, and that's the best way that we can. That's the best tool that we can use to reproduce the problems and issues that we see the rover having. So, for example, we used it for testing about dropping of our samples onto the Martian dirt. We actually found that unexpectedly some of the samples actually stick upright. Now that's not good. So we're going to be photographing each of the tubes as we drop it to make sure that the samples have fallen into a horizontal lying position in our December case drop, actually. So yeah, that's how we solve a lot of problems. But of course, it could be those people in the audience, the kids in the audience, who could also be looking at solving not only problems with the rover, but problems with the samples that we get back, because when we get the samples back in 2035, we're going to need lots of ideas on how these rocks were created and what they can tell us about, whether humans can live on Mars and plant our biology onto the surface, and also make it more habitable for humans in the future.
Fantastic. That's a really cool problem solving issue to set for our students today. And I just love that that's so clever that there's another kind of analogy rover that you can use to solve those problems. Going to careers in space, again, back to Alice, where we have a twofold question from Wollongong Public School and Tumut High School, asking about medical jobs in space and what careers are available to ensure the space exploration is keeping our planet sustainable. So sustainability here on Earth and medical jobs in space. Can you tell us a little bit about, what we might find and what we could expect?
Space medicine is something you can already study. One of my friends is just starting out her career as a doctor, but at university, space medicine was her research topic, and she was looking into the impacts of muscle mass on bone density when you're living and working in space. So that's already, just as a health effects of being in space, that is already a field that you could consider going into. The other really important thing with medicine and space, of course, is remote medicine. We don't have a fully equipped hospital just based on the International Space Station, and we can't really send one with us when we go to the moon or Mars. So being able to do medicine remotely through remote connections through robotics, etc., in space, and using space for better access here back on Earth is another really important field if you're interested in both medicine and space. The other question was about space sustainability. That's also a really cool one, a really broad one too, because that's looking at, potentially using space observation to monitor and, make sure we're doing the best we possibly can here on Earth, using the information we can gather from space, but looking after the space environment and our local orbit is also really important. So space environmentalism in that sense is something to consider as well. This is something that, if you're interested in it, fields like getting into law and regulations could be useful. Would be useful, could be interesting to you, I should say. Lots of companies are trying to come up with better strategies for working sustainably in and with space. And any type of environmental work that you'd be doing these days does actually rely on space technology and observations. So yeah, there's heaps of options there too.
Nice. And I love that, keeping space clean, and that's directly relevant for keeping our planet clean as well. Final question coming from East Hills Girls Technology High School for Sandra. What did you find out through your studies on the International Space Station?
Oh my gosh, the studies are ongoing, and one of the fun experiments that I was involved with, although this experiment continued past my increment to several increments in the future, but it was a biochemistry experiment to try and understand what our bodies absorb, what happens to the human organism in zero gravity. And so I kept a food log, a food diary of everything I ate and drank. And then I had to do a blood draw and a urine sample every 30 days. And so the experimenter, the principal investigator, was collecting these samples from a lot of astronauts so he could sort of get a better feel for how our bodies change in nutrition. So that one was a really fun one. And then I did some experiments with materials, and tiny materials suspended in a liquid. They were magnetic, and we applied a magnetic field to see how that behavior would manifest again without gravity. Surface tension takes over, and colloidal systems with tiny little particles suspended, behave somewhat differently. If you want to get a good feel for all of the kind of science that's going on in the space station, NASA has a website where you can go look up all of the ISS research and some of the publications that have happened. And so you can just type in NASA ISS research into a search engine and get the full story of everything that we've been doing on the space station since humans first arrived there in November of 2000.
Fantastic. Yet another idea for your 2023 planning. If you'd like to look up that International Space Station website, you can also look out for the Australian Virtual Astronaut program, which I think is running again next year. That's an amazing program that you can do. Look out for that on the schools industry, student schools industry partnerships program. Thanks for Young Space Explorers for, just developing the forum and developing all of this. Thanks for your amazing questions, everybody, today. Do check out Careers with STEM. We do have a magazine on space where you can find out more about space careers. And thanks to Fizzics Education for running this in the background. We hope to see you all next time. This will be recorded. We'll send you it out on the list, and you can find it on the Fizzics Education or Careers with STEM's websites if you'd like to share it around. And thanks all for the amazing guests that we've had today: Sandra Magnus Hall, Alice Fairey, Adrian Brown, Ted Tagami. Thank you all for just sharing your incredible knowledge with all of us today. Big virtual thanks, everyone, for the panelists.